The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone, and welcome to PNSQC's summer webinar series. This is our 35th annual conference, and we're building up to our conference in October with a series of webinars. This webinar is on requirements-based web application security testing, and we're featuring our guest speaker will be Bhushan Gupta, who is an expert in software security, and he's also going to be speaking at our conference this year at a workshop as well as a paper presentation. So welcome, Bhushan, and it's great to have you here. Just a little bit now about our organization. We're the oldest software quality conference in North America, now in our 35th year, and every year we have an annual conference held in Portland. The conference is run all by volunteers like myself. My name is Phil Liu, and I'm moderating today's webinar. But first, let's talk a little bit about some of the house rules. House rules, everyone is muted except for the speakers, but feel free to go to the panel in the GoToWebinar control panel and ask questions, because we'll be able to ask questions to Bhushan throughout the webinar and try to make it as interactive as we can. If we don't get to them, we also have questions at the end, and we will be answering any questions that were not answered on our blog. And as well as you'll be receiving information on the recording and slides as well. Today's hashtag is SecureTest. So if you want to tweet along with us, use that hashtag. Like I said, my name is Phil Liu. I'm one of the board members of PNSQC, and I am a volunteer. You can find me online and so forth. But today is really about Bhushan. Bhushan Gupta was an invited speaker last year at our conference. He's got over 20 years of experience in software development life cycles, and is an avid researcher in web application security. He's also part of academia as an adjunct professor, and so he's got a really broad background, both from an academic side as well as commercial side, and is quite a frequent author and speaker. He's also, really into quality as a certified Sigma black belt. And I didn't know this, but he's a dedicated Toastmaster. That's really unique, Bhushan. So welcome today.
Thank you.
I'm just going to go ahead and turn over to you and let you do your thing and talk up and teach us all about web app security testing.
Great. Good morning, everyone, and welcome to this webinar. We are going to talk about how do you achieve high security confidence level for web applications. It's a very broad subject. The security of a system really depends on quite a few elements. There is a application platform involved, which means you have an operating system, and then you are using a development environment, be it J2EE or a third-party software that is including open source. Most of the time, we are not really writing the entire application by ourselves. We leverage things which are available outside. A lot of things are being used from open source resource, which adds another variable to the security where you are not confident how secure the open source code is. The other very important variable is the software development life cycle, which starts from the requirements to the release, and how we do things really matters in the world of software quality and software security. Also, the best practices we use while we are developing a software, and I've highlighted a couple of them here. I would say hardening is one of those things which we normally would not be worried about unless we're looking into security. Coding standards, normally apply to whatever we do for, for web application development or any other development we do. Coding standards are important. Today's trend is to do penetration testing on a web application. What this basically means is that we tend to test the software from hackers' perspective. People include OWASP Top 10. Hopefully you've heard of OWASP. And OWASP Top 10 has a list of 10 highly rated vulnerabilities which everybody wants to test. And we try to test the periphery to do any breaking into the code.
Hey, Bhushan, there's a question that came in. Somebody was just asking about the OWASP top 10, and then it says plus other vulnerabilities, and they're wondering if there are other vulnerabilities that are really important that are not in the top 10.
A lot of times you see vulnerabilities in operating system. And this is what we are referring to here pretty much.
Okay.
Sometimes you also see OWASP Top 10 doesn't really refer to the coding practices. Although the coding practices apply to remove the vulnerabilities according to OWASP Top 10.
Right. Okay. Thanks.
You're welcome. The challenges here are very unique. First one is that we only have limited development time. We cannot test for a long time because we have a deadline to make. However, the hackers, they can keep on hacking as long as they want. There's no time limit on that. And there are so many kits available today which are very, very cheap. You can go buy a kit if you want to hack an application and deploy that. And that we cannot do as developers because it costs money and it takes time. So those are the few challenges when we try to hack according to the penetration testing. That is the main message here. You cannot achieve the high level of confidence. Okay. So what would be the alternative in this case? Like we build the software quality from inside out, we should do the same thing with security as well. We should build the security inside out, which basically means that control the security aspect of an application throughout the SDLC. And then you close all the gates from outside as well. So what we're saying here is that you need to build security in your SDLC plus have penetration testing to substantiate and get a high level of confidence. I always want to say that security is not on its own. It is an attribute of quality. It should be included as part of the software quality. We're going to go through some basic principles of security. If you look at the security triangle, the three aspects of security are confidentiality, integrity, and availability. We will elaborate on this. So if you look at confidentiality, that basically means that the access should be only to the authorized people. Now, hackers are malicious, but they could also be unintended access which you don't want to provide, but it happens because somebody didn't want to access your application. That could be internal, but they did get into the code or into the areas where they are not supposed to. Okay. So that's part is confidentiality, maintaining the data privacy by access control. Integrity is no one who is not authorized to manipulate the data should be able to manipulate the data, whether the data is stationary or in transit. Integrity should be maintained. Availability is the application is available for whatever time period we need to have it available. Is it 24/7, 365, or it is just we're only available during business hours? So availability basically means that the application is available as long as it needs to be. I have a little comment here which says not all data is worth protecting. There is certain data which is worth protecting if you have some information which doesn't cause any harm, then you don't need to protect it. It's a very simple diagram here which shows how the data flows. You have the client on this side, and you go over a network using some kind of protocol, and then you have a web server which interacts with the backend. You can have any applications at the backend. This is how normally a web application environment is set up. Now, like I emphasized before, the weakest link is access control. A lot of vulnerabilities come or happen due to access control. Let's look at access control. There are a few things which we need to think about when we talk about giving access to somebody. The very first one is identification. How do we identify somebody, whether this person has the right to be in the application or not? Normally, it's a user ID or ID, normally we call it. Authentication is the person I'm allowing to go into the web application. Is this person authorized to go into that application? And okay, let me say it again. The second one is authentication, where we check where if you're coming into the application, are you really the person you're claiming to be? And there are some ways to identify that. We normally do that by a password, which could be a character string. We also apply methods where you can show me something you have, like a PIN, or when you go to a place to do any official business, somebody says, oh, show me a driver's license to prove that you are who you are. And the third method of authentication could be a physical characteristic of yours, maybe a fingerprint or some biometric, some other biometric method, which can be used to identify you are who you are, or to prove you are who you are. Authorization is not everybody is allowed to look at all the data. So if you're going to look at some data, are you authorized to look at that data, view that data, and manipulate that data? So that's the authorization part. And audit is an important aspect where we really want to make sure who came to the system or who logged into the system and what did they do while they were in the system. This is important. If a breach takes place, it's also important to know who the general users of the system are. If I look at basic requirements, start with identification. Everyone who comes to the system has to have an ID which is difficult to guess. Now, there was a survey some time ago, actually it was on Jimmy Kimmel's website. They had a survey, and the most used password was 123456, which is very easy to guess. So identification is very important. And I have listed a few more requirements for identification here. User ID should not be shared with other users, and the processes, if the processes are important to hide, are important to not reveal the user ID. There is a captcha requirement which wants you to prove that you are a human being, you are not a robot, and that's becoming more and more popular nowadays. So there are a few requirements for identification. Authentication, I mentioned the password that is normally used as a characteristic to authenticate somebody. And some basic requirements are that nobody should be able to guess it. So you have to provide some complexity to it. And if somebody cannot guess it, it's hard to crack. So complexity crackability is one main point here. Now, if somebody forgets the password, then you have to have a recovery process and provide that password to the person. Now, failing to not provide the right password should be provided with, or should be helped with timeout. Do you want to secure the system? You should have a timeout. You lock out somebody after a certain number of attempts. And then the number of attempts should be well defined, 2 or 3 or 4 or 5. And when somebody wants to recover their password, they shouldn't be able to just go to the log, to the portal, or shouldn't be able to change the password on the portal. There should be some other mechanism like sending them an email and changing the password through that mechanism. And the passwords are never distributed. So what I have shown here is requirements of confidentiality for authentication part. Now we will develop the requirements for each part of the confidentiality. There is a little bit more information on authentication here. What is important is storage of password on your system. You should never try to store your password in database in plain text. It should also be hashed or encrypted. These are some of the biometric mechanisms. Fingerprints I mentioned about. Retina is important. I mean, there is a trend to use more advanced mechanisms to authenticate somebody.
Well, that's interesting because fingerprint has definitely become quite common on mobile apps. But what about what would be the next one that you see would be coming in the future that would be quite common and popular?
I would say Irish probably would be the next popular. This is easy to, I shouldn't say easy to, it's easy to perform. I believe easy to perform. Retina is not that reliable because I think retina could be subject to some disorders. Irish probably would be the next.
Are there third-party plugins to allow that kind of biometric scanning that you could use in a software program?
I'm not aware of one at this point.
Okay.
It's a good question. I'm not aware of any at this point, third-party software. I think the other point I want to make here is that when you have business processes in your application, they should be treated as subjects. They should not be just given access to everything. A process should only be able to manipulate the data it's supposed to. That's something we don't often pay attention to. So processes should also be treated as subjects. Integrity of the data. Few things which are important here. Integrity basically means that data should be accurate all the time, whether it's stationary or in transit. And basic requirements would be provide access which is role-based. If you look at old systems like Unix, their exercise are very role-based. What are you doing to do with the data? Based upon that, I'll give you the access to that data, or part of that data, or part of the functions of that you can manipulate, that you can perform on that data. Many other things, we are trying to also see that any malicious attempts logged with adequate tracking. Tracking is important because we really want to know who is coming to the system and what's their intention on the system. Recovery mechanisms should be in place where you have, if just in case your data gets compromised, you should be able to build the data back up. Most of the time we have a redundant data server which can be used to back up the data.
So Bhushan, we have a question that came in. They're wondering, you talked about malicious attempts logged with adequate tracking, and they're wondering, what are the requirements for a malicious attempt? How do you flag a malicious attempt to know that you should start tracking it? Or do you just track all? How do you, yeah.
You track all.
Okay.
And then your auditing would then tell you if there is data breach, then you would have to do work backwards, and then you try to see who made that attempt. But you track all the data.
Right. Okay.
Any user coming in. Yeah. Okay. Availability is just the time your application should be available. TDOS has been a very effective technique hackers have used where they will just flood up your website and they will start responding. They will just keep spinning the process after process, and your application will not be available. So if you look into the requirements, based upon the requirements, you can build some security controls. So let's look at the first example here. I said maintain during data transition and at rest. That control would be, to meet the first requirement, the control would be you have to have secure transmission with a strong encryption algorithm. So if you look at all these controls, if you look at malicious login attempts, means you have to track every login attempt. Because you don't know when somebody is coming in, you don't know whether the intent is good or malicious. So you have to log every event that is happening. I mentioned about recovery mechanism. So depending upon your requirements, you need to build what controls you should have to protect your data. There is an example of data integrity here. I have highlighted some secure design principles. Defense in depth basically means you should have layered defense. There will be multiple ways to make sure that you're checking identity at different places. Fail safe. You maintain confidentiality by securing the rapid recovery. You need to be able to rapidly recover the state of the system, and that's done by redundant systems. We all know about least privileges. You should never provide anybody access. The base access, the lowest level access, then as opposed to higher level access, because you need to always start somebody with lower level access and then raise their access. The next one is weakest link, is production of the weakest code. So if you look at your entire application, try to find out what is the weakest link in my code. in today's environment, it happens to be the password. That's how we try to, most of the time. I mean, there are other methods too, but most of the time, most systems get hacked by stealing passwords, stealing cookies, and things like that.
Is there like another, like number 3, in terms of the weakest link? You mentioned protection of the weakest code. Is there ways to find that out in your code? Which parts are weak?
Anytime you're providing the access to the database, which holds private data, those will be the areas which will form the weakest links. So when a hacker comes in, they come in to get important information from you. So that would be the area. Now there are other ways people can do that, like say cookie stealing. They can get that while your data in transit. There is man-in-the-middle attack, which would cause stealing the data while data is traveling online. So there would be also situations where you may be vulnerable to attacks. This is more like generic area here where you can. So the other thing is social engineering, which is people are trying to get to your information by fooling you. Okay. A lot of times that happens too, and some of the breaches have happened just because social engineering. Disguising by who they are and try to get in the system. Here is OWASP top 10, and I have root causes for all top 10 vulnerabilities. The reason here is to understand what can cause those vulnerabilities and what the remediation would be. So if I try to summarize that this is first 5 of them and next 5 of them, and if I try to summarize what the reasons are, this is what we get to. So to be able to make your system secure, your developed environment has to be smart, and we will talk about this. And I have mentioned some languages don't provide a foolproof system. For example, C, if you're not careful in programming, you can easily cause buffer overflow, and that would put the data in an area where people can access it. It can cause vulnerabilities. So developed environment is important. Access control, we talked about that. And looking at everything we have talked so far, input validation is really, really important. There are a lot of things which can happen due to non-sanitized input. So SQL injection is typically one of those which would happen because you're not sanitizing the input coming in from the client side. We talked about how to protect the information while it's online, like you need to do a secure transportation with encryption. And whenever the data is traveling or is in stationary situation, it should be encrypted. A lot of times we don't pay attention to system hardening. So if you look at top 10, if you look at what other requirements are provided, these are main things here which we need to be worried about. So your SDLC, whatever you're using, you should include some very specific things which are highlighted here to make sure that the root causes are taken care of. One of the things I have highlighted here is repeatable process to measure attack surface index, and we'll talk about that a little bit. How do you measure attack surface index, and why is it useful? It's a simple thing you can do every time you make a change to the system. Other things are encryption algorithm. A lot of times people try to write their own algorithms, which is not the good thing because there are strong encryption algorithms which are available out on the shelf. I mentioned secure data transport. So the other thing I have is use of tools. There are scanners you can use. There are other things, SQL Map they use, which can give you a good feel for how good your application is. Now, based upon these requirements, based upon what we are concluded from OWASP Top 10, what should be my approach? So I have to have a multi-pronged approach. I have to reuse inspections. I must emphasize environment verification, system hardening, and I also do traditional testing as well. The static code analysis is in old days, we used to compile the code and we'll get warnings. Now, a lot of times we didn't pay attention to warnings. Static code analysis is just that. It gives you an opportunity to look at the warnings and then see what I should do about this particular warning and how it can impact my system in terms of security.
Bhushan, a question came in. Are any particular static code tools that you use that would be good for identifying security issues in the code?
We'll talk about that, and I have listed one here. So there is Veracode. Yeah, it's pretty well used, and I think they have been in business for a while. HP has a tool called Fortify. You can use that. Both of these tools are both static and dynamic. That basically means that they can be used for just compiled code and also for executable code. And I also have mentioned the other scanning tools, Zap and Burpsite. There is a little bit of description down below for each of those. Okay?
Okay.
Something I should really emphasize here is your environment verification. System hardening is important because a lot of times we put an application together and for different things, let's say for database server, we just use the default settings, which may not be to the best of our interest. We have known about fake install reviews. I used them 20 years ago when I used to work for HP, and they're just the way to take out the problems out of your system, whether it's quality or security. You can use it for different purposes. You can check how my development environment is. You can look at that. Am I causing any buffer overflows, anything like that? Input validation, for sure, you can check for the input that's coming in. Am I validating that or not? You can also look at coding practices. So you can really apply that for a set of different things to make sure that you have a good system altogether, good environment, good system altogether. Logistics is fairly simple. Team of experts gets together, have a review session, log the issues, and follow up through those. The pitfalls here are you require a very broad expertise. You need to be expert in terms of security. You need to be expert in operating systems. You should know the operating system altogether, language, coding practices, and it's time consuming if you have a big web application where you are referring to multiple pages, multiple views. So it's not that comfortable or it's not that efficient when it comes to a big web application. I also make a point here, it may not always work well with agile development. The reason I'm saying is that you really have to dedicate some time in your iteration, which is mostly 2 weeks. People use 2 weeks nowadays. in your iteration to make sure you do review. Fitting it in is what the issue will be very likely. But it still should be done. It may not be that convenient in agile development. Static code analyzers, they run on mostly on compiled code with the debug on so that you can see all the warnings that are coming in. And they try to give you security problems. They try to highlight the security problems. You get a nice log of what the vulnerability is. And I know at least the Vara code gives you a numeric index by which you can gauge how good your application, how secure your application is. They're commercially available. I don't know exactly how much they cost because I can't afford one anyway. But I played around with Vara code and it's very intuitive. You can set up your controls or your environment controls, and then they'll give you warnings about vulnerabilities, tell you, and they give you an index of how secure you are. I haven't had a chance to play around with Fortify. The problem with static code analyzer is they give you false positives. You may get a vulnerability which does not really exist. It's false positive. And they require resources. Somebody has to really maintain them all the time. If you look at dynamic code analyzers, and like I said, those two are also dynamic code analyzers. They work on binary codes. They're basically simulating a vulnerable scenario for you through the input, client input. They're trying to see different vulnerabilities, and then they give you the list of vulnerabilities you may have in an application. And they can, like I said before, they can quantify your app in terms of vulnerability. They can give you an index which you can say, oh, am I secure, am I not secure? They they give you a range as well, how secure you are, based upon what vulnerabilities they have come across. Environment hardening. I mentioned something before where I said that a lot of times when we get third-party applications or we get servers and things like that, they are set up with default values. Anytime that happens, anytime you have that situation, you need to make sure that the privileges login levels are adequate. Not everybody should be an admin when it comes to a database user. So you want to make sure that you have right login privileges. Also follow the principle of least privilege. You start somebody with the lowest privilege. I have been in organizations where there is a access control list, and I go to the administration and I say, hey, I want to add somebody to this list. They will say, well, why don't we give you the access and you can add whoever you want, and that access will be there forever. First of all, it's wrong to give me that access. Second of all, I never lost that access. So we don't want to do those things. They cause problems down the road. The other thing I'm mentioning here is disabling unnecessary features. If you don't need it, there's no need to enable it. Make sure you don't enable things which are not necessary. Change control is very important. You see security related changes coming out all the time from different vendors. So you want to make sure that your versioning is important and your change control is planned and happening on time. Simple things to avoid big problems. Now, scanners, when I talk about scanners, I'm talking about these basic scanners which sometimes are available for free, and they give you lots of information that you can use to make sure your code is in good shape. What they do normally, and I'll talk about more about how to use them, but they give you a good description of what type of vulnerability do you have, or what vulnerability do you have in your application. is basically an initial assessment of the website, and looking at that, you can follow your further test plan. You already know what you need to fix. One of the major benefit of a scanner is you can guide your test plan by seeing the results of a scanner. And sometimes it can also help you out with your overall quality. And what we're doing today is we have these couple of scanners, ZAP and Burp Suite. We run those, and based upon those, we know how secure our application is. I'm sure people in the audience probably use one of these scanners. They're good, but they're not the only thing that you should be depending upon. Most of these scanners, especially ZAP and Burp Suite, those are the most widely used ones. They are proxy tools. They are between the browser and the application, and when they are used as a proxy, they will intercept everything that is coming from the client side, and then analyze it, and then try to give you whether you're vulnerable or not. So most of the time, this is how you use it. You can also use them as standalone, meaning that you can just install the tool and run it from outside. If you do that, running from the outside means running as a tool. If you do that, you're depending mostly on the data or on the input data you have, and then you can analyze that data. But when you go through, when you use them as proxy, then you can use the application as you would otherwise, and the data goes to the tool, and then you know what the vulnerabilities are. The difference is, standalone, you don't have any control of the input data, but when you use as a proxy tool, you can really provide the data you want to test with.
Yeah, Bhushan, one more question came in. They're wondering about the ZAP tool. The ZAP tool provides a lot of reports, as far as after you run the tool, but the reports are quite cryptic and quite a bit of information. I think you had mentioned also that there sometimes is quite a few false positives. How can you go through such a long report and really figure out what's important and what's not important?
So they also, good question. They also categorize based upon the severity of the vulnerability they give you. They also categorize them. So first focus would be, let me look at the high risk priorities first. You have to pick and choose here. Let me look at the high priority risk first and deal with those, and not worry at this time of everything else. And once you have addressed the first top high risk priorities, then you go on from there. The reports being cryptic is just a matter of reference here. I have run it multiple times, and the results I get, at least they are categorized, and I know where to pay attention.
Mm-hmm. So it's really
that's the first level to look at.
Yeah, I really need some expertise sometimes to look at these reports, I think.
And that comes with experience. More you run them, better you get at it. Also, they also give you a way where you can control your environment. I would not want to go too deep or to different levels. You can keep your level 2 or level 3 where when the links are embedded, then you don't want to go too deep, because then your tool runs forever. You get large reports as well. So when you start with maybe 1 or 2 levels. Don't set all the environment to be on to start with, and just turn them on as you go through.
Ah, okay.
Yeah. People might do that. I'm going to go through my entire website. Well, if you do that, you're going to get a big report, and it's going to take a long time too. So you configure it incrementally. Okay.
Yeah, thank you.
Mhm. And the other thing is they do a lot of things. They do scanning, spidering, you can do fuzzing, you can do a lot of things, port scanning. So that's why you need to really be specific what I'm really looking for from these tools. If you start using it for everything and that to configure it to do multiple things at the same time, your reports are going to be really long and confusing. And I just support this point. There are good things about scanners, language dependent. They give you good initial assessment. And I would say that you can't just depend on a scanner. You have to have more robust SDLC and more robust testing. If you have and there's some shortcomings here, things like they cannot test for social engineering. And if you're running them in a standalone mode, you can only get predefined set of attacks. Basically, that means is the input is standardized. You can't really change the input. That's when you go for fuzzing and things like that. They are free. Zap is free, and free things don't get updated very often. So you need to be aware of that as well. I'm going to spend a few minutes here, couple minutes on what I really like is the subject I really like is attack surface analysis. And here's a very basic picture here. If you compare the two castles here, this is castle, this is a home, you see it's pretty well protected. You don't see many openings here for attack. But if you look at this place here, the windows are open, the garage door is open. So what I'm going to present, give you a brief taste of what is surface analysis and how does it help you. What we're trying to do here is understand what the different attack vectors are, and based upon those vectors, we try to derive a numerical value for your attack surface. Where can you be hit? What is the area that somebody can penetrate your system? It's very simple approach based upon actual entries to your system. If you look at this diagram, there are different areas people can enter a system. HTTP call, web server, browser application, OS. And then what we try to do is look at these vectors. What's the degree of distribution? How many leaks do you have in your system? Okay. Do you have static pages or dynamic pages? If you have static pages, you have less, excuse me, static pages, you have less probability of being hacked because there's not much going on. You're not collecting data from the database. The other vector is your security mechanism. Are you just using HTTP or using HTTPS? Your input, what can you include in your input when you try to get to your system? Is cookies, what user roles are you supporting, what kind of rights do you have? So there are different vectors that have been identified. You can measure your index through or based upon these vectors. And once you have measured each one of these vectors, and you can provide, and there's a process behind it, but I just giving you an example here where you can have different values for different vectors. These are the different vectors I shared with you: access control, rights, cookies, and you can come up with a numeric value of your web application in terms of attack surface index. Okay. What does it do? It tells you how secure your system is. Minimum value of ASI would be 0. That means you're very, very secure. Maximum value could be 60.79. And now this, like I said, there's a scientific method behind it. So you can then say, well, if I have 19.2 on a scale of 0 to 60.79, I'm quite safe. I'm not that vulnerable at this point. On the other hand, if your attack surface index goes to higher side, that means you're quite vulnerable. It's a simple tool you can use. It's not automated, but the mechanics is not that hard. And you can achieve a value which you can use every time you make a change. You can use it and know how badly or how good a change you have made or how bad a change you have made. I really like this method. I have shown some characteristics, and I think the one I want to highlight is scalability. You can really scale your method to a small site or a big site. The other thing is that developers and QA people can effectively use it. Developers can assess it when they are developing or making a change to the code. They can realize how bad a change they have made or how the things have changed. All right. So let's look at how do you really weigh or assign weights to your vulnerabilities you have in the system. When you're doing your testing and you are trying to now see how your how severe defects are. So there is a method called DREAD, D-R-E-A-D, based upon how much impact there is on the data. Can it be reproduced? Can the vulnerability be reproduced? What is the exploitability of the vulnerability? Is it easy to exploit, or is it going to take a lot of efforts to exploit? And the actual impact. Am I going to lose all my data? Or I'm going to impact all my users? And that would give me the actual impact of the data. And how easy it is to really discover that vulnerability. So based upon these categories, you can assign some values, and eventually, after you know these values, you can find a DREAD index, which will give you the severity like we do for the normal defects we find in the system. This is a way to scale or to find out the severity of a vulnerability. It has been used fairly widely. Whenever we are doing anything, we also want to measure things and do a report at the end. If I was going to report things, this is what I would report. How many vulnerabilities did I find with their severity? What kind of threat exposure do we have? You can get that from ASI index fairly easily. You can also look at vulnerabilities found in each phase, like we do for regular defects. And the other thing would be, what measures would we take to contain the risk? Whenever we want to report, there are some things which are important for us to report. If you look at test efforts in a regular SDLC, when you're talking about building a secure system, there is a lot which goes into design. 15 to 35% is in design. So if you really want to build a secure system, you need to have a good environment and a strong design and all the practices we have talked about so far. Just a couple slides on agile development. I know there is a large percentage of applications that are developed using Agile SDLC. Basic things again, you need to do threat modeling. What method you choose to do threat modeling can be something which you really like and something which is easy for you to do. And that needs to do for initial. Let me be a little bit more specific here. So you have different iterations. So what we are saying in kickoff iteration, you decide your tool, threat modeling, how do you want to provide access to the data? Are you going to be dealing with attack surface index or not? Do you want to determine that for every iteration or not? Hardening policies. So basically what you're saying in kickoff is plan your development for rest of the iterations. Okay, that's your kickoff part. It also includes your design and code review management. How would you review that? And I really believe in a release criteria, whether it's a small application, big application. What would be release criteria? When would you say that my application doesn't meet the release criteria in terms of security, so I'm not going to release it? I think that is the one check you must perform.
That's
And
interesting
how would you
because, I
really?
mean, what kind of criteria would you have? Like the number of threats
You can have
that you
you can have
find?
a number of threads. Yeah, you can have a number of threads. You can also do like it normally when we talk about regular quality, we say we're going to fix all severe defects. In the same situation here, we're going to fix all severe vulnerabilities, and if we don't fix, we have a plan to handle the risk if there is a breach. It would be the basic aspects like we have used in the past. So again, um, the severity of the vulnerabilities, how are we going to handle those if there is a breach, what policy should have we followed the policy for service for the hardening, what is the versioning policy, all those criteria. Some of these are policies that should be in place, and that becomes a criteria itself. Do we have all the policies in place? It's a criteria, these criteria. So if you look at that, the situation we're going to have, if we're going to have a breach, what would we do? And then how do we take care that we don't take care of the code that there is no breach? What else should happen? So that would be the criteria for these situations. Some in a regular iteration, you want to do your review. There will be new requirements, so new security controls, review policy. Again, there will be new configuration, hardening, environmental hardening. Again, you will have to run your tools, static and dynamic, ZAP, and whatever you want to run. And then find out what your new vector is after you made the change. This is a regular iteration. And the release iteration, you should know your surface index. Regression testing, penetration testing should be included in this particular case. And then your overall quality assessment, like we do open security defect analysis, what's the probability of the breach? What will be the impact? And what is our mitigation plan? I think what is most important is have a mitigation plan. A lot of people don't do that from security perspective, and I think it's time to emphasize that we need to have a mitigation plan. There is more on acceptance criteria. The acceptance criteria is same as release criteria, interchangeable words and sometimes. There's a lot of things here. I know I have only a couple minutes left, so I think this would be my conclusion here. You have to understand the vulnerabilities, yeah, and understand how they can be exploited. Have a threat model so you know what your threat is for your application. Create a secure SDLC so that your testing is less and your building you spend more time in thinking through security as you build the software. What are the potential breaches, and have a contingency plan. Important things there. And that was my last slide.
Yeah, thanks, Bhushan. I think what's really interesting is being able to build security into the requirements and actually having exit or release criteria that are security based. Just like you would have other types of acceptance criteria, really. And I think that a lot of us, think of security last, just the same way that we may think of performance and doing performance testing last just before release to see if everything's okay. But at that point, it could be too late, right? In terms of trying to find stuff, and maybe it's cost prohibitive to find all these problems at the last minute and try to fix them. I don't think there's any more questions. if we could move on to the next slide. That's really great to have you here today, Bhushan, and for all those in attendance. I know that at least for me, I know that Bhushan covered a lot of subject matter and really just the surface. It's too bad that we didn't have more time, but he is going to be at the conference this year, and he's going to be presenting a technical paper on requirements-based web app security, as well as a whole workshop on some really cool tools. I know I'm really interested in the workshop because doing hands-on stuff is really helpful. So we look forward to seeing you all at the conference in October. And stay tuned for our next webinar, which will be in 3 weeks with Katie Sherman. And we'll be announcing that webinar coming up, as well as the links for this webinar in terms of YouTube and SlideShare and so forth. So thanks very much, everyone, and we'll see you in October. Thanks, Bhushan.
Yeah, thank you, everyone. You're very welcome.
Okay.